There. So hopefully our last part in this series on review of Algebra 2, 1 through 75, identifying all the real roots of 4x to the fourth plus 3x cubed minus 4x squared minus 89x plus 22. To get there the quickest route possible, what I'm going to do is I'm going to plug all of this into our y equals. All right, we're going to go 4x caret to the fourth plus 31 x to the third minus 4x squared. Oh, wrong one. We want squared. Minus 89x plus 22. And what I'm going to do is I'm just going to hit second graph. What we're looking for is places where y equals 0. All right, and I find one right here. You see it? Negative 2. So we know that negative x equals negative 2 is a root. How many roots should we have? Anybody know? We should have 4 roots because we've got an exponent to the fourth. Okay? So let's see. Are there any others that we can spot? Those all seem to be going really big. The rest of these might not come out to nice, easy to spot things. Okay, so what we're going to do for now, we're going to hold that off to the side, and we know x equals negative 2 is a root, and that's one that we can find, right? So what we're going to do from here is we're going to use synthetic division to see what else we can find. So we got 4, 31, negative 4, negative 89, and 22. And what we're going to do is we're going to use negative 2. We got 4, so that's going to be negative 8. What's 31 minus 8? You guys are going to help me out here. 31 minus 8. 23. 23 times negative 2. Negative 2 times 23. Negative 46. Which would be what? Negative 52. Is that right? Or sorry, negative 50. Negative 50 times negative 2 is 100, right? All right, what's 100 minus 89? Should be what? It should be 11, right? 11. Negative 2 times 11 is negative 22, giving me a remainder of 0, showing that negative 2 did go into it evenly, right? Okay, you say, why would we do all that if we knew negative 2 went into it evenly to begin with? Because what we want is we want this 4x cubed plus 23x minus 50, or sorry, x squared minus 50x plus 11. Okay, that's what we wanted right there. Okay? Makes sense? Now, because we still have all these other roots to find, what we can do is we can go in here and we can hit graph and see where about, there was our negative 2, and we see a bunch of these others really close in here. Okay? So for those x values should be pretty small. So as we go back up here, again, we're looking for where y equals 0, but notice we're not, where y equals 0, we're not getting anything else between there, which means they're all kind of small decimal type irrational numbers and values. Okay? Okay. Okay, the hard part about this one, and I hope we don't see this question on our test, is that from here, in order to find out what types of other things would go in, if you remember where we've looked at 4 and 22, right, we would put, we'd find the factors of 4 and we'd find the factors of 22, both the positive and negatives, and set them over each other. Now it would give me my list of options of things to plug in. All right, now we still have that list, but now it's out of 4 and 11. And so we know from looking at the list that 1/4 should work. Right? That 1/4 would be on that list. 1 goes into 11, and 4 goes into 4. Okay, so if I was to set up synthetic division again, we'd have 4, 23, negative 50, and 11. And if we tried 1/4, okay, we'd bring the 4 down. What's 4 times 1/4? What's 4 times, or 1 times 4? 4. 4 divided by 4? 1. All right, so I'd put that 1 right there. What's 23 plus 1? 24. So multiplying by 1/4 is the same thing as dividing by 4. What's 24 divided by 4? 6. So I'd put that 6 right there. What's negative 50 plus 6, or 6 minus 50? Negative 44. Negative 44. What's negative 44 divided by 4? Negative 11, all right, which is 0. All right, so we know that 1/4 x equals 1/4 is another root. All right, at this point, I'm finally at a 4x squared plus 24x minus 44. At this point, what I would do with this is I would plug this into the quadratic formula. Okay, I would take negative 24 plus or minus the square root of 24 squared minus 4 times 4 times negative 44 all over 2 times 4. Question? No? Okay. So we've got negative 24 plus or minus all over 8. We'll find out what's inside that square root. Okay? So I'm going to do that in my calculator all at once. I got 24 squared minus 4 parentheses 4 close parentheses times parentheses negative 44 close parentheses. I get 1280. 1280. Okay, I'm going to just check. Does the square root of 1280 reduce? It does not. Okay, so we would have to simplify that radical. So 1280, if I divide that by 2, I'm getting 640. Divide by 2 should be 320. Divide by 2, what's 320 divided by 2? 160. Then 80. Then 40. Then 20. Then 10. Then 5. So we're looking for 2's, right? Does anybody need to know if they're in National Honor Society? No. Okay, so let's look at our list here. We got 1, 2, 3, 4. That's 2 times 4. What is that? Or sorry, it's going to be 2 times 2 times 2. 16. So it should be 16 radical 5. Okay? So what I'm going to do here is I'm going to erase part of this. I'm going to erase this guy right here. Okay, and bring up, we've got negative 24 plus or minus 16 radical 5 divided by 8. And what's negative 24 divided by 8? Negative 3. And 16 divided by 8 is 2. Okay, so this is 2 answers. Here's an answer. Here's an answer. Lexi, you were looking at the bottom. Did you see negative 3 plus 2 radical 5 and negative 3 minus 2 radical 5? All right, so did we find them all? The hardest thing to do in all of this is to get that 1/4. Okay, that's the hardest one to get out of all of it. All right. So I will look for that question. If I see this question on the test, I will try to replace it with something else. Okay, just because to show your work on there is going to be pretty extensive, but it is good practice for us. All right, number 32, find all possible values of inverse sine radical 3 over 2. Give your answer in radians. Okay? Okay, so let's see, we'll look at this. Inverse sine radical 3 over 2. Okay? We can take our calculator here. Second sine, square root of 3, close parentheses, divided by 2, close parentheses. I get 60 degrees. Okay? So 60 degrees. Okay. Let me show you how that works on paper, though. Okay. Sine is opposite over hypotenuse, correct? Okay. Opposite radical 3, hypotenuse of 2. All right. Do we see this as a reference triangle? The 1, 2, the radical 3? Right. In that, what is opposite of radical 3? In a 30, 60, 90 triangle, what's opposite of radical 3? Is it 30, 60, or 90? Okay, so we need to, okay, it is radical 3, 1, and 2. Okay, those are your unit circle special right triangles. Okay, so this would be 60. So this is 60 degrees. Okay, all right. Is that the only place, is this the only quadrant where I would get a positive radical 3 at? Or can I get that in a different quadrant? Okay, I'm going to see that we don't know. What about over here? Would this still be a positive radical 3? Right, because it's above the x-axis, right? It's representing vertical, right? If I dropped it down here, it would be negative radical 3, right? If it was down here, it would be negative radical 3. Okay, so do we see how it works in quadrant 2? Now the hypotenuse is always going to be positive no matter where, but so we want, what we're wanting is we're wanting to maintain that ratio, that radical 3 over 2. So that works both here and here. But what we're looking for is where this line exists at as a degree. Here it exists at 60 degrees. Okay? What we're meaning is from the initial side to there, it was 60 degrees. What is it from here to here if the reference angle is 60 degrees? What's 60 degrees shy of 180? 120? 120. Okay, so I have lines that fit that ratio at 60 and 120 degrees. Now, the last thing that they want is they wanted my answer in radians. How do I get degrees into radians? How do I get degrees into radians? Does anybody know? Okay, so we need that. You're going to take the number of degrees and you're going to divide by 180. So in this case, let's take 60 divided by 180 and get that fraction. 1/3. So we're going to write that as pi over 3. Okay, do we remember that a little bit? How are we going to get radians for 120? 120 divided by 180. What's 120 divided by 180? Two-thirds? Okay, so how am I going to write that as a radian? 2 pi over 3. Check the bottom. Let's see if those answers are right. Okay, good. Okay. You guys aren't making me feel very confident here. All right, number 3. Number 3. What is length of side Q to the nearest tenth of a meter? The length of side Q. I'll give you a hint. It's going to be a log of it's going to be a law of a trig function. Is it? But we have to determine, is this going to be law of sine or law of cosine? Law of what? Law of sine. Okay, let's see. So you guys are fairly confident about that. Law of sine has me set up a proportion. What would you put on the top left? Do I need to find anything before I start this? Am I missing anything? What am I missing, Maddie? Need to find the other angle. You're absolutely right. I need to find this angle right here. So we're going to take 40 plus 69. That's going to give me 109. What am I going to do with 109? subtract it from 180. All right, so what's 180 minus 109? 71. So we needed 71 degrees right there. Okay, 71 degrees. Now that I have that, okay, can I begin to put this thing together? All right, what's going to go top left? Sine 71 over what? Over 6. Okay. What about top right? Sine 40. Okay, sine 40 over what? Over Q. Okay. Now because it's a proportion, I cross multiply and divide, correct? All right, Corey, help me out with that. You've kind of been speaking up here a little bit more. 6 sine 40 over sine 71. What I would do is I would do 6 sine 40, hit enter, then I would hit divide, and then I would, divide by sine 71, right, and find out what my answer is going to be. To the nearest tenth, so 1 decimal point. What do you get? 4.1. 4.1 meters. What's the answer at the bottom? 4.1. Very good. Okay. I'm going to keep moving. You guys have the video, so you'll be able to catch up to anything that you might miss. Let's see. Let's try to find 34. 34. A school survey is distributed randomly, selecting classes of students. Each student in each selected class is asked to fill out the survey. What type of probability sample is this? I mean, we've got cluster samples, we've got stratified samples, we got simple random samples. I think it's a cluster sample. Okay. What's it say at the bottom? It says cluster. Okay, so basically because they give these surveys to an individual class and then a class is selected to fill out this survey. So like homerooms, right? We give this out to every homeroom and then we select one homeroom at random and we have that homeroom fill out the survey. So this is a cluster sample, okay? Just so that we see it on the board for people that don't listen, cluster sample. Okay, 35, last couple of questions here. Find a number of solutions of the equation, 7x squared plus 3x plus 4 by using the discriminant. Can we tell me how I'm going to use these numbers, how I plug them into the discriminant? No, that's, no. I don't know that we know what a discriminant is, do we? All right, so if you take the quadratic formula, right, which is negative b plus or minus the square root of b squared minus 4ac all over 2a, all right, and I want to know what kind of answers I'm going to get, right? The discriminant that tells me what kind of answers I'm going to get is what's inside the square root, okay? Because if this is 0, then all of that cancels out, and what I get is negative, I get this number over this number. 0 gives me one real solution, okay? If what is inside that square root is a positive number, then I can add and I can subtract that number. I can divide by something down here, and it might be a decimal, but anything that's positive is going to give me, over 0, anything over 0. Maybe we'll change this a little bit. If it's greater than 0, so if it's greater than 0, what I'm going to get is I'm going to get 2 real solutions, right? And if it's less than 0, I'm going to get 2 complex. Because if it's less than 0, what I'm getting inside of here is a negative number, right? I'm getting the square root of a negative, which means my answer by definition is complex, right? It's imaginary. So what we want to do whenever they say use the discriminant, I don't need to do all of this. All I need to do is the b squared minus 4ac. So how do I take these numbers here and do that? Okay, so what do I write? What's my b? 3. So 3 squared minus 4 times what? 7 times what? 4. What's 3 squared? 9. What's negative 4 times 7 times 4? Probably a big negative number, right? Negative 112. All right, what's 9 minus 112? Negative 103. All right, so how many solutions am I going to get, and what are they? I'm going to get 2 complex. What's it say at the bottom? 2 complex. Okay, not 2 as in T-O-O, like is, oh man, that's too complex. It's 2 as in the number 2. Okay, do we understand that now? Hopefully that was a good refresher. Okay, 36, last question. And you guys have till tomorrow to study for the test, right? You got like 4 or 5 parts of this. Marguerite is given the function y equals 6 plus square root of 2x minus 7, and x equals 2, 3, 4, and 8. She notices that 2 of these values, let me kind of move this over so we can read the rest of it. 2 of these values are not in the function's domain. Which 2 values are not in the domain? What are the values of y for the 2 x values in the domain? Okay, so let's look at this. Says equals, right? So we got 6 plus the square root of 2x minus 7. Let's try 2. What's 2 times 2? 4. What's 4 minus 7? All right, so is that going to be I'm getting an imaginary thing there. All right, what about 2 times 3? 6. 6 minus 7 is negative 1, right? Does that work? No. What about 2 times 4? 8. 8 minus 7 is 1. So 4 works, okay? So what we're getting is 6 plus 1, right? Right? Because the square root of 1 is 1. So the answer there, whenever we have f of 4, okay, f of 4 equals what, 7? Okay, let's try 8. What's 2 times 8? 16. What's 16 minus 7? Is it 9? 9. So that would be 6 plus what? What's the square root of 9? 3. All right, so f of 8 equals 9. All right, what's the answer down at the bottom?
Out of the domain 2 and 3 values of y is the same.
What? Let me scroll down here because I couldn't catch all that. I'm about half deaf, or maybe more than that. I'm not sure. 30. Oh, 36. Right? Out of the domain 2 and 3, values 7 and 9. Okay, so we got 7 and 9. So I think what they're saying is which 2 don't work. Is that right? Okay. So you know, which 2 values are not in the domain. So that's why we're saying, 2 and 3 not in domain. And then it says what are the values of the ones that are in the domain? 7 and 9. Okay, does that make sense? All right, we can hit stop on this, and you guys can study for your test.